Hello everyone. Today's lectures we are going to discuss the topic stoichiometric points defect in solids. In these chapters we have see these defects like a stoichiometric defects which is arise due to various types of the points which can be included to found these defects. So first points we have see the various types of impurities we can produce the defect in the crystals. The common types of defects which is found in crystal like a impurity. The impurity may be two types. First one, the impurity may occur a position normally by the host atoms and hence it is called as substitutional impurity. This type of impurity which is observed in closed packed crystals. The impurity atom is of almost same size as same as valency of host atoms. So such a types of impurity which is present in the crystals like a foreign atom at having a regular site of this crystal. So sites of this crystal as well as the foreign atom, they will be same, and therefore such a type of impurity which will affect the closure pack or the arrangement of these crystals. Next, it may be lodged in the voids or unfilled volume of the crystal lattice and termed as interstitial impurity. It means that some voids or unfilled volumes also observed in this crystal lattice. For example, such a types of crystal lattice which is there, but some of this void or this foreign atom which is present in this crystal lattice, and therefore such a types of defects also observed in this crystal lattice. Next type is a interstitial impurity, means that it is a crystal lattice, some foreign atom at void which is present, and this defect is observed like a extra atom which is found in voids between the regularity occupied site in the crystals, like this 1 2 3, and this is 3 and this is 3. So these atoms which are there, but one of these extra atom which is present are called as the foreign atoms which is present at void. So interstitial impurity which is present in the voids between the regularity. So atom in void is of the same types in the lattice site and hence it is called as a self-interstitial defect. So why it is a self-interstitial defect? Because the lattice site and atoms in void which are the same, and therefore it is named as self-interstitial defect or such a types of impurity which is present in the lattice. Next is a vacancies. So you know that vacancies means it is a free space which is present in the lattice, like it is a unoccupied lattice site. This space which are not occupied by the crystals, so it is a free space which is present in this lattice, and therefore the defect which is observed in the crystals. Second point, it is a place or the position of a missing atom or ion in the crystal. Some of that linearity of these crystals or order of the crystals which is disorder due to the position or the missing of atom can take place in the crystal lattice. Next point, it occurs when atom is missing from its lattice site or it leave its site. These types of defects which is observed or vacancies are there because some of these atom can missing are there or the sum of the atoms leave this site and to get the free space are here. Next point, the crystal site are rendered vacant by removal of structural unit. This defect is referred to as the vacancy defect. Why it is a vacancy defect? Because it produces in the lattice as a free space between the atoms. Point defects may occur in stoichiometry as well as the non-stoichiometric crystals, but the stoichiometric crystals are arise in which the number of positive and negative ions are exactly in the ratio indicated by their formulae, which is called as the stoichiometric point defects. So stoichiometric crystals like the AB type, it having the crystal as is made from A plus and B minus ions. So these types of crystals, the stoichiometric defect which is found in stoichiometric compounds, it is also called as the stoichiometric point defects. It is two types of defects observed in ionic compounds like Schottky defect and Frenkel defects. Now we have see the Schottky defect. This Schottky defect which is observed in ionic compounds, this defect discovered by the name of the scientist is Schottky in 1930. This defect is arise due to the lattice points which are unoccupied in the crystals. These unoccupied points which is called as vacancies. You know vacancies? Vacancies are the free space which is present in the crystal lattice or the unoccupied space in this lattice. The vacancies is created by missing atom or ion in the lattice site. You know that vacancy are created. How will you create this vacancy? Vacancy is created by missing atom or ion in a lattice site. In this term is called as Schottky defect. Such a type of defect observed in ionic crystals. For example, ideal crystals. This ideal crystal which is present two ions like A plus B minus, the arrangement of such a constituent ion in the crystal which is maybe perfect means it is ordered the layers, that is all lattice points which are occupied by ions constituting the ionic crystals, and lattice point is vacant. So such a type of crystals, it may be all points they will be occupied. Okay, so these pictures of these ideal ionic crystals like A plus B minus, we are clearly shows that all points they will be occupied by each atoms, like the A plus, B minus, A plus, B minus, A plus. So these red colored cations and green color anions, all these cations and anions will be occupied by each space, and therefore these structures like ideal ionic crystals, this shows that no space which is vacant are there for these ionic crystals. But these defects which is occur in ionic crystals, the cation and anion leave their site and create two vacancies. Which is two vacancies? The vacancies are due to the missing of cation and missing of anion. So these two types of vacancy are created. These defects or such a type of defect, they involve cation and anion vacancy in the crystal lattice, which is called as Schottky defect. Such a type of defect containing the equal number of cation and equal number of anion, they will leave and to get the vacancies. Means one cation and one anion, they will leave and to create the two vacancies at a time. The number of cation and anion left behind the crystal is the same even after missing the cation and anion. Means at a time the cation and anion will be left behind in the crystals, or the missing of cation and anion. The crystal, they will be electrically neutral because one cation and one anion, they will be left behind in the crystals, and therefore the crystal will be electrically neutral. For these pictures, we are clearly shows that for sodium chloride molecules, we observe that some of these cation and some of these anion, they will be missing with each other. This white colored are shows that the missing of this cation, and this white color are shows the missing of these anions. So this one cation and one anion, they will be missing with each other, and hence it shows the neutral of the crystals. So all these cations and anions in this crystal lattice of the sodium chloride does not occupy all space. These space and these space which are unoccupied means that one of these cation and one of these anion, they will be missing with each other. The vacancy may be distributed at random or the pair. For example, the 1 milligram of the grain crystal, it contains 10⁻⁹ atoms having 10⁴ Schottky defect. So number of such defects per cm³ at given temperature we can calculate by using the formula n is equal to capital N raised to minus W upon 2 RT. W is equal to work, capital N is total number of site per cm³, and R is a gas constant. It is appears in ionic compounds having high coordination number. It is also appears in positive and negative ions. Do not differ very much in size, that is ionic ratio is 1.